Okay, good morning class.
Good morning, sir.
Today we're looking at exponents. We will be looking at the examples for exercise 2.5. Is that correct?
Yes, sir.
Please settle down. And that's on page 47. Okay, so the question says simplify. 2.5, page 48. The question says simplify. Is the marker, yeah. Sorry? Okay. So you got 5 to the x times 5 to the 2x over 3, 5 to the 3x. Okay? So when we're multiplying and bases are the same way, add the exponents. So we got 5 to the x times 5 to the 2x, so we add that, becomes x plus 2x. Not so? And when we're dividing and bases are the same, we subtract the exponents, so it's minus 3x. So it's 5, x plus 2x is 3x, and 3x minus 3x is 0. Anything to the power of 0 is? Okay. Any confusion there? No? Let's look at the next one. So here, in the second example, we have 2 to the 2n minus 1 times 4 to the n plus 1 times 2 over 16 raised to the exponent n. So, are the bases the same? No. Okay, so we can't subtract the exponents, we can't add the exponents if the bases are not the same. Okay. However, 4 we know can be written as 2 squared. 16 can be written as 2 to the exponent 4. So it's 2 to the 2n minus 1 times 2 to the 2 raised to the power n plus 1 times 2 over 2 to the 4 raised to the n. Okay. So what we do now? We need to get rid of the brackets. So that will be 2 to the 2n minus 1 times 2 to the 2n plus 2 times 2. If there's no exponent there, there's a 1 over 2 to the 4. Again, what's the rule when we're multiplying and bases are the same? Add the exponents. When we divide, we subtract the exponents. Okay. So that will be 2n minus 1 plus 2n plus 2 plus 1 minus 4. Okay.
So,
Yes?
instead of saying 2 to the power 4, could you have said 4 to the power 2?
You could have said 4 to the power 2, yes? But then the bases would not be the same. Then you would have to break 4 up again into 2 squared. So we always tend to break it up into the smallest, or into its prime products of its prime factors. Once it's in that format, and then take it from there. Alright, so this would simply be 2n plus 2n is 4n, minus 4n, cancel. Minus 1 plus 1 cancels, so it's 2 squared, which is? Okay. Any confusion there? Any questions? Taylor? You look surprised? You with us? Okay, you among the living still. Right. So now we're looking at the example on page 48. Example now is on page 48. Again we are asked to simplify. We got 2 to the 2n minus 1 times 6 to the negative n plus 1 times 27 raised to the exponent n over 18 raised to the exponent n. Right, so what must be broken up here? 6, 27, 18. Break it up into products of its prime factors. For those of you who don't know how to do that, we know that 6 can be disposed into 3 times 2. So it's 3 times 2. 27 can be written as 9 times 3. 9 can be written as 3 times 3. So it's 3 cubed. Okay, 18, which is 2 times 9. 9 is 3 times 3. So it's 2 times 3 squared. Okay. Otherwise, you can use the calculator as well. 18 equals, whoops, firstly. So it's 18 equals shift, and then that factorized button. 2 times 3 squared. 9 can be written as, so 27. This 27. You can try this on the calculators. For those of you who haven't done it before. But it's 27 equal shift and factorize 3 cubed. Okay. So let's go with that. So it's 2 to the 2n minus 1 times. We said 6 can be written as 2 times 3. Okay, relax people, settle down. Times 27 can be written as 3 cubed raised to the power n over 18 is 2 times 3 squared raised to the n. So what we're going to do now is get rid of the brackets. Okay. That exponent on the outside, it needs to be multiplied by every basis exponent on the inside of the bracket. Okay. So that's going to be 2 to the 2n minus 1 times 2, there's a 1 there. 1 times negative n plus 1 is negative n plus 1 times 3, there's a 1 there. Negative n plus 1 times 3. 3 times n, 3n. And this is all over 2 to the n times 3 to the 2n. So what's the rule? When you're multiplying and bases are the same, add the exponents. Okay. You're multiplying and bases are the same, we add the exponents. Which means to say, only the exponents of the bases of 2 can be brought together. And likewise,
can you please report to
only
the office?
the bases of
Please report to the office.
can be brought together. Okay, you guys understand? Okay. So that means to say that's going to be 2 to the exponent. 2 to the exponent 2n minus 1. So minus n plus 1.
My apologies for the incorrect name. Mbalendle Kumeni in grade 12. Can you please report to the office?
N
Mbalendle Kumeni in grade 12.
plus 3n.
Please report to the office.
Okay. It will be 2. 2n minus n cancel. That cancel. So I put a 0 times. That cancels, leaves you with 3 to the. Anything to the power 0 is? 1. And 1 times 3 is? 3. Okay, you guys understand?
Yes.
Okay. Next one. Again, we ask to simplify. We got 9 to the x plus 1 times 3 to the 3x minus 4 over 27 to the x plus 1 times 3 to the x minus 2. So 9 can be written as 3 squared raised to the x plus 1 times 3 to the 3x minus 4 over 3 to the power 3 raised to the x plus 1 times 3 to the. So what do we do now? Multiply the exponents. Okay. So that's going to give us 3 to the 2x plus 2 times 3 to the 3x minus 4 over 3 to the 3x plus 3 times 3 to the x minus 2. Okay. What's the rule when I'm multiplying and bases are the same? Add the exponents. Okay. That would say, as you can see, all the bases are the same. It's 3. So it's 3 to the 2x plus 2 plus 3x minus 4 minus 3x minus 3. It's either you're going to say 3x minus 3 or you say minus, open brackets, 3x plus 3, which then in turn gives us minus 3x minus 3. You guys understand?
Yes.
So you always notice I will change all the signs as I did initially. And then this here, minus x plus 2. That will simply give us 3. 2x plus 3x is 5x. 5x minus 3x? 2x minus x? What is 2 minus 4? Negative 2. Plus 2 is 0. Minus. So it's simply going to be 3 to the exponent x minus 3. With that you should be able to do exercise 2.5. So that brings us to the end of this lesson.